Yeah, hello. Good evening, everyone.
Good evening, sir.
Good evening, sir.
Okay. So this session is for quiz 1 revision session, okay, which contains week 1 to 4 only. And particularly, if I say week 1, 3, and 4, because week 2 is just an introduction or kind of overview of machine learning project. So it's like it has everything, but kind of can maybe skip it also. It doesn't have any effect on the quiz. But week 3 has a lot of things. So uh, yeah, same thing. Okay. So what we'll do is um, okay. So one thing I wanted to tell you about this is so this MLP is a course of programming, right? So as a concept wise, there is nothing much covered in the course. So there's not much will be there in the quiz also. So how will you do it is like most of the questions, if you know you can do it, if you remember you can do it. So you have to maybe practice a bit. The programming side you have to practice a bit. If you have done the programming, then you will feel it's very easy. If you haven't done, then you have to just go through it again and again. So this is not something you can maybe understand. It's like a language, any language. You have to practice it, then only you can do it. Right? So maybe you can go through like previous year question or something like that. Okay. Um, so what we'll do is, uh, okay, is there any topic you want me to cover before I start, or so what we are going to is we'll do some questions I have. I'll put in front of you, and we'll see what uh, are the solution of it. Okay, because this kind of questions you are going to solve in quiz. Okay, then I can start. Well, okay. Okay, so this is first question. So let's say this kind of data is given to you, and this kind of question will be there. Okay, so just in case you're thinking, is it? Yes, it's going to be there. This kind of question related to pandas. It could be, it could have different kind of questions, but you get it. Like pandas, you should just get prepared with it. Okay, so watch. Just at least go through the collab which is shared with you in the supplementary content, right? So some content is given, the collab is given. Just go through it, and maybe you can, most likely you will be able to solve all the questions. A few might be tricky, but that's okay. You depends how it goes, right? So this kind of data is given. So columns are given as this. So like I have like 3, 4, 5 columns are there, and then in each column some data is there, right? So name of that thing and Maruti. So from the data, you can maybe think like it is a car data, right? So name is given like Verna, Corolla, MS. These are names of the car, and then these are the companies or manufacturers. Then years of purchase, year of purchase, yeah, and price in lakhs. So price is given. This is the price in a row, and then petrol. Right? So this is our data set. Data is being collected. Now, what are the questions being asked? Like, so what will be the output of the following code? So something like this is given, right? So what is the shape of this data frame? So what um, sum? Okay. Uh, the question is what is shape, but you have to take sum of that also, just in case. So what do you think would be answer?
Line, sir.
Uh, 11. Okay. Um, okay. So the reason is we have 1, 2, 3, 4, 5 columns, right, as we see here. And then we have 6 rows, like 1, 2, 3, 4, 5, and 6 rows, right? So, better. So, okay. So we have like, uh, so yeah, something like this. So 6 rows and 5 columns and sum of that, right? So that is the question being asked. So 11. Now, okay, this is a question. What will be the output of the following code snippet? Um, it's asking about the value counts. So what does value counts does? Like what when should we use value counts?
To count the unique values.
Unique values in a column, right? So some column is given here, and that how many unique values are there and how many times they are coming in that column. For that reason we need it. So that's what it will give, and it's asking of that, right? So year of purchase. So this is a year of purchase. So like 2007, 7, 2 are there. Then 2007, one more 3, right? And 3, then another, all are like unique. So 3, 1, 1, and 1, right? So in that, it's asking about what is the value of T 2007, right? So it will be, so first we are doing is we are creating data frame kind of thing, which has value counts. It will give you year and a unique value of that year of purchase and how many times it's coming, the count of that. So in that we are searching for T207, right? So this is an index we are giving to search the value, and that value is what is the count of it, right? So 1, 2, and 3 is the answer for this, okay? This kind of question. Now it's asking describe it and tell me the shape of it, and then give me, so shape will give you row and column. It's telling us how many columns are there in describe, right? So in describe how many columns are there, that's what the question is. So what does describe do? You should know that before answering that. Uh, okay, uh, so that's something like this data is given to us. Now, now it's asking what is df dot describe, right? So it will give you statistical values of the column which has numerical values. Okay. So wherever this categorical kind of data is there, we are not including in describing of that because statistical values are not there. Like uh, so only thing it has is like mod, right? Or uh, yeah, mod you can find for category kind of data set, but nothing else. But it is giving you like mean, max, what is 25%, 50%, right? Something like that. So as of now, we have two columns which are numerical, and that's what it's asking, that how many columns are numerical, and it will give a description of it, right? So shape of it, and then column of it. So if you run this, uh, so without even running, like you won't have this running and all, but to understand things, I am running it. Okay. Uh, Example, if I do like, okay, like this was the question, right? Print out that. Okay. Fine. Now, okay. Now, what is this? What will be the output of the this? Right. So, what are codes snippet given here? This is the data set. Right. And I'm putting both of them in screen. So, yeah. Now it's okay. Okay. So, okay. What is the question about? Anybody? Okay. So this question is about like, tell us what is like year of purchase is greater than 2008, and fuel type is so this is like not equal to petrol. So anything other than petrol is okay, and it has to be greater than 2008, right? So if I see greater than 2008, there are like three rows are there which are greater than 2008, right? And of that, I want petrol type not, sorry, this fuel type not petrol. So I think this is not petrol, and this two are diesel. So it should be two answer. Okay, so answer of this should be two. Right?
Could you please tell why did you mark 3 for
This
no?
is not answer.
Okay, what was the answer for option C?
That is also two. Answer is two. So this is the answers. 11, 3, 2, 2. Okay, this is because of footnote. This mark. Okay, so here also answer two. Now, okay. So given the data, which of the following options will provide the same output? Okay, so that's what. Um, so if you do this, df.ilock3 for year of purchase, right? Um, so okay, what you are supposed to do is ilock does this, it indexes, or you can go to that value, right? That row and column wise. That's what you can do using this. So what we are trying to do is, we using df.ilock, we are going to reach that row, because 3 is given here, right? So if you write like df.ilock and 3, you can reach to that row, third row. So it starts from 0. So we are now in third row. You can say
Sir,
this is what it is. Okay, and then it is asking, give me the value and year of purchase column. Right? So year of purchase is a column in that, and give me value. Right? And it is 2018, right? So that's what first A option is. Now what is B option? B option is, tell me, using lock, it is giving me the row value and column value as well. So both are doing done using lock only, right? Both of the things. So here we have done two things. First, we did something with ilock, and the second part is something we have done using like that's how you can actually traverse the Pandas series or something like that, right? So it's a usual Pandas, or even Python, you can do, right? In Python, we write column metrics, or we traverse the metrics. That's how it's done. And here it's done using lock function of Pandas, right? Both of them. Now, this will also produce 2018 because we are going at third row and year of purchase call. Now, what is this df dot I log 3? So row is that, and it's saying second column of that, right? So what is second column in it? If I go here, so this is 0, 1, and second. Again, it is year of purchase. So same thing. Nothing changing here. Now here it's saying go to -3 and the second column. So second column we know year of purchase. So what is this -3, right? So if you write -1, then alto or this kind of row will be indexed, right? Or will come out. Now this is -2. This is -3, which is same as 3, right? So 0, 1, 2, 3. If you go in reverse direction, that is again like -3. Okay? So that's why this is also same as this. Now, what is this last one? It wants first thing. What we are doing here is we are this is called Boolean indexing, right? So we give us some condition that is it matching with it. So it will give you true, false kind of thing, and based on that you can index or you can filter the rows, right? So that's what it is doing. Like if I show you here now something like so this will give you true and false, right? So this true and false are there. Now wherever true is there, you can get that values. So if I just write uh, I put a bracket around it, right? Df, so it will give me wherever true is there, right? So this column is appearing, or this row is appearing because of this thing. Okay. Now what I have to do is I have to find year of purchase in it, right? So that's what it is telling me. So if I write dot also, so there are two ways to write something. Like let's say I can write df year of purchase like this. So if I do this, or another thing I can do is df dot year of purchase. Both are same thing. Okay, so you can see I can use dot or this uh, what do you call this double comma, right? So whatever colon you can put around it, and you can uh, read it. So both the ways are same thing. Now here it's used like another way to write it, like dot year of purchase, and then of that read I log 0. Okay. So if you do this, like first let's see what is greater than 10, right? Greater than 10 in price in lakhs, right? So greater than 10 is of price in lakhs, or price in lakhs is this. So okay, only one row is there which has greater than 10, and of that we are reading this year of purchase. So again, it will come 2018 on, right? Uh, that's what it will be there, and you can run and prove it. So if I do this, it's again same, right? Uh,
Sir, yes,
yes, yeah.
that only I wanted to ask what you did.
Okay, okay. So if we haven't used ilog, then what would be?
It's a
Uh,
data frame.
yeah, so then it won't be. It will be like a data frame kind of thing. Okay, so this is for reading purpose. Maybe it could be like this also. I think it would have worked. Uh, no. So something like this is required. Uh, uh, yeah. So here we can see all of them are true. So answer is actually all of them, right? So A to E, all of them are correct except F, because they are providing same answer. Now, if you would like to see the most frequent car manufacturer in the data set, which of the following can be used, right? So we just now saw earlier somewhere like here, what does value count does? That we can find the unique values and how many times they are appearing in the data in that column, right? So count of that. So we can use that to find the most frequent value, right? So we can do that. So most frequent values we can find using this value counts operation. Just be sure that count values is not a function. Value count is a function. Okay, and we just now saw that we can write TF like this as a manufacturer, like putting this inverted commas, okay? Or what we can do is without or just putting dot, we can write it, right? So both ways are valid. So this is a valid way to find most frequent value of it. Something like this we can do. How would you like to see, if you would like to see the most frequent car manufacturing data, which of the following can be used? Right, so one is that. Another thing is you can use group by. So what you can do is you can group by using uh, the manufacturer itself, and so if I does this, okay, so if I do this manufacturer, if I write, and if I run this, like it will not show anything. It will show there's some data frame, generic type, and something, right? So this is actually value of it. So you have to maybe read something out, or so you have to choose any some row or something, just so you know we get a value. Now you can choose any column, doesn't matter, to get a count. So for example, I do this, and it will give you the count of how many cars are there and price in lakhs, right? So this is, if I use count, then of course like it will give you count of them, right? And if I use mean or something, then something valuable should have come, like it would have done some kind of statistical computing, mean or something. uh, so here what they did is they gave fuel type as a column. Okay, use that and find count. So yeah, that is also a valid um, column, like count. Sorry. So same thing. Um, okay. Yeah, if you can do this way as well. So this is just some little bit different, but same thing. Okay.
Hello, sir.
Yes,
Sorry to interrupt, sir. Will the PDF be shared,
yes,
sir?
yes.
Where it will be shared?
Um, okay, I'm not sure about that, but we can give you. Uh, so in portal we'll put it. We'll send the announcement also. Yes, okay.
Okay, sir. Thank you, sir.
Sir,
It will be in the
uh,
portal.
this
Yeah.
paper was already discussed the day before yesterday.
Uh, okay.
Yes,
Maybe
sir.
not all of the questions. Is this also okay? Is it already covered? Mm, like this question.
Yes, sir.
Yes, sir.
Okay. Uh, mm, I was not aware about it. So in TA session, it was covered, or I don't think so. It was covered in our session.
Yes, sir. In the last
So,
year session, he covered this paper.
Um. Okay. So okay. Then then what we can do is maybe So maybe we can cover this mock unit then. Okay, so I think
Yes.
it has also same question somewhere, but rest we can cover. So okay, so is being used for, I think so. This kind of questions you can expect not coming in the quiz. Like will not give such like that you have to remember something like this to load the digit, something like that. But the answer is this. Yeah, you just know it. There is no logical. What is the correct sequence of operations while building an ML model? Okay. Okay. So when we do prepare an ML model, what we do
Sorry to interrupt, sir.
is
Can I ask?
yes.
Sir, we saw last year PYQ. There is more practical than theoretical. This term in mock you given more theoretical, more than practical. So it is similar type of.
It will be both like theoretical, practical, not like so few theoretical questions are there, but mostly it will be code based only. Some code will be given and you have to
So actually, I
answer.
am done mock paper. That's why I'm asking. Here is more theoretical question there in this mock. That's why I'm asking, rather than practical.
Yeah, so then it's the same thing. Like this kind of question you can expect in quiz. Not much theoretical, like uh, which is so it has like several more questions, right? I think so. Then
Sir, like, could you please, uh, like, sir, there are 21 questions in this MOOC. So, how many questions we can expect in Quiz1?
around 20.
Okay.
Around 20 you can expect. Right? So more like 20, but not much. 20 is the like you can take from that.
Sir, maximum is 20.
Maximum is 20. Yeah, not maximum. Like you can expect like around 20. So maybe one or two more could be, but not uh, not much more. Like it won't be like 25, 26. Okay, like maybe one or two, 21, 22, but not more than that. So okay, then let's see what we
And
can do.
sir, each
Uh,
week is equally weighted or data-based?
no, it's not equally weighted. You can see like that there won't be much from quiz from week 2 because it is like intro to things, right? Intro to ML or something like that. So not much from that, but you can expect more from week 3 and week 1. Okay, so
So what about week 4?
yeah, week 4 will be there. So week 1, 3, 4 you can expect, but week 1, 3 has more weightage. Okay.
Okay, sir.
Okay, sir.
So this is this is maybe last one. So this is a website I can
Actually,
share.
sir, in 2024, there is a lot of practical type question. Before that, 2024, there is a lot of theoretical type question coming in PYQs, what we say.
Yeah, so now you can expect more practical kind of question, not theoretical. It
Okay.
won't be there. So let's say this is okay. So this was from last term, like this paper. I think we can go through this also. Okay, not an issue.
Okay, sir.
have this. So just now we did, but let's do this also. So which option will give the total count of cancelled flights in the data set? So this kind of data set is there where cancelled is something like this. So it has true and false, right? So what you can do is you so what if you do sum of it? Can you do sum of it? I don't think so. You can do sum of it.
Sir, is null.
So if I do is null, and then is null will give me just like, is there a null value present in it or not, right? So then
None value means only any a that
yes,
there is nothing inside that.
Sir, the sum will work, I guess.
so we have to count trues, right, of this.
Yeah, so true will
Yeah, so
get the value 1
summing the
and
Boolean column counts the number of true values.
true will count as 1 and false will count as 0. So the sum will be all the true values.
Okay, so I think some will work. Wait a minute. So
Okay.
uh, so if I have, let's say, data frame, and let's say if I have like cancelled or something, okay, and it has like true, false, true. So this is my TF1. Okay. Now, can I do TF1 cancelled dot sum? Yes, I can. So yes, so sum will work. I can do
Some
count,
will,
but that will not make, yes.
some will only count
True.
calculate the true.
Yes, true. It will take it as 1. So
If we do value counts,
then it will give you both the
count
counts.
of true and the false, no?
3
Yes.
as
So
a
it will give separately both of them.
okay.
If you do just counts, then it will give you count of it, like uh, right. So 3. Then again you can't figure out which are true and false. So if I do that way, then not. So sum is the right answer. Is null, we don't have to do it because it will give you, first you'll find null values present in it or not, which is not here. Then it will sum it. So it will be 0. Okay. It
Got it.
is give me, this is the length of it. So that is like a find the length of a array, which is like whatever is like 11, 12, something like that.
Sir,
Yes.
sir.
So
So
Yes. Yes.
can you explain the difference between sum, count, and shape?
So sum is you do addition. Okay. So if true values are there, it will be taken as a 1 and you can add it. So 1 1 1 like that it will add. So here like 1 0 1, that is equal to 2. Okay. Like 1 plus 0 plus 1 is equal to 2. And if you do count, then count is just counting, right? Like how many are there. So it will count all of them. Then another one was, what was another one? Is null.
Shape, sir.
Shape.
Yes.
Yeah. So df dot shape, if you do, then shape is something will give you what is, how many rows are there, how many columns are there. So if I do this, so it doesn't have brackets. So actually this was from here. But if I do for df1, it will give me 3 and 1. So 3 rows are there. You can see 3 rows and 1 column is there. So that's what shape is.
Row column in the format, right?
Sorry?
Like shape will give in the format of row column, right?
Yes, row and column. Yes,
Yeah.
row, comma, column. Now, which of the following columns will add a new column that shows true if the flight was not delayed? So, okay, so we wanted something like so we first what we are doing is we are creating a column which is a DF on time, right? So you can create column like this, and then you are giving a value something like on that, right? So equal to will give the value to it. Now condition you can set that what is that, right? So what we are doing is we wanted true here, right? So that shows true if the flight was not being delayed, else false, right? So it's greater than equal to okay, so we have to see what is there in the delay minutes column first, right? So here, right? So it has numbers in it, and if it is greater than equal to 0, then it is delay, right? That's what it means. So greater than equal to 0, then true, and else false. So that's what this will do on time, right? This is logic, like that B is the right answer because delay. So first we are doing,
it is delayed, sir. It is not delayed.
so we want true for that, right?
True for not delayed.
Oh, we want true for not delayed. Sorry. So
Less
that
than
means
equal to.
less than equal to. Okay, yeah. So if it is less than equal to delay minutes less than 0, yeah, then it is on time, right? So otherwise it's false. Correct.
So
Okay,
could you explain it again? Like I didn't get.
so here this delay minutes are given that 8 to 14 minus 10, like that, right? So if more than 0 is there, that means it's delayed, right? Not on time. If it's less than 0, then it is on time or equal to 0, less than equal to 0. Correct. So that is the logic which is
Okay, sir.
being used.
Got it.
How can you filter the flights that have delayed due to weather? So weather has what kind of values? Is there a weather? Did you understand? Delay. Okay, delay reason is that where weather is a reason given, and what we have to do is where that have delayed due to weather. So we can do df delay reason is equal to weather. This is a okay. This is the way we can do definitely. So first way we can do it or not. Delay, then we are doing str, then we are asking contains whether or not. I think first will also work. So this we are converting it to string. So this str will convert something to string. Then this contains is a function of that, and then does it contain whether or not. So this str and all is, I think it's a Python function. So like str Python method. So it has being like capitalize. We want it contain or something like that.
Sir, it is a panda specific function.
Is it? I think it is. Maybe.
Sir, it is a panda specific function.
Yeah. So dot str is it? But when we have str, Does it contain weather or not?
No. When you type str.contains on Google, it is appearing on the Pandas documentation.
Okay, could be that. Str dot contains. Yes. So in Pandas it has. In Java it is there, but in Python. So okay, so in contains, basically what you do is you whatever value is given, does it contain or not? It will say that, right? So it will find that for some of this.
Is it
Right,
giving
so
Boolean value?
yeah, it is giving Boolean, true or false. Okay, like this, like str contains. So here they are searching OG, and regex equal to false. You can make regex equal to true and give a regex something like its formula as well to find something, some pattern. So that is pattern searching you can do. But here what we are doing is we are searching the word itself. So that's okay. We don't have to put regex equal to true, and that will give it true or false, and that we are doing using Boolean indexing. Now delay reason is equal to whether. So if I do this, it will again do the Boolean indexing, and df whether, this kind of column is not that, right? Df whether, yeah, that kind of column is not, so we can't choose that. Okay. Now which option will sort the flight first by airline in ascending order, then delay minutes in descending order? So this is something on short values. So we wanted so sort the flight first by airline, and so first by airline, then by delay minutes. Okay. So this is df dot short is not a function in this in pandas, but pandas has short values. Okay. Just in case, like let's say if we have df, and if I do, let's say df dot short by its name, then uh, environment. So short is not correct, but if I do with short values, then that is the function which pandas has, short values, and then you can give by what you want to do it. So here we can do, like if I do it with name, then you can see by name it is being shorted now. Earlier it was Wagoner was here, right? And now it is at last. This index has changed. Now if you wanted to sort by two things, you can maybe do like let's say manufacturer. So first it will do by name and then by manufacturer. So you can see name and then manufacturer and something like that, right? So uh, now maybe you can do ascending also. So let's say if I do true and false, so it will do. So this is what you have to do, right? So true and false, like if I do
So
true, then true.
instead of manufacturer, could you take year of purchase?
Say year of purchase. So let's see what then do we can maybe write again, and then do, let's say, second one as false. Okay.
Still sorting.
Is it sorting though?
So, like, what it means? If it is true, it is doing it ascending in order, or if it is false, it won't sort
No, so
according to
first it
ascend
will do the sorting by um,
by name.
name only, yeah. So and then it will do inside it. So you can see, so let's say it did by name, so which are unique. So there is not much it has. So if I do with manufacturer, then it will be different, right? That makes sense. Like if I do manufacturer, then maybe difference will be visible. So now you can see Honda is there. Then inside Maruti, okay, all of them are 2007. Let's see if I just change a little bit data. So this is 2008. Another Maruti is in 2009. Okay. So now if I refresh, so it has changed like 2008, 9, something like that. Now let's say if I do by first manufacturers, right? So Honda, Maruti is there. Then I'm doing ascending to the year also. Okay. If I do again, then you can see it has like first it has done
It seems like it is
Sir,
doing.
in name you need to
Change the
change to
manufacturer.
manufacturer.
sorry, yes, I should change it to manufacturer. Right. Okay. So again, like Honda is there, Hyundai. Then inside Maruti, you can see the change is there. Now it is in descending up. Okay. So if we put false, then that is descending.
So, can we say like if it is false, then it won't do the in like convert the sort into the like descending order. It will give the order in such a manner like a normal row. Is it
Normal.
like it won't sort anything? Is it like
It won't shorten. Then don't put it.
no? I mean to say like if it is ascending,
Yes.
ascending is true means it is ascending in order proper.
Yes.
If it is false, is it meaning that it is descending in order?
Yes. Yes. That means that is descending. So see, you want to short it, right? That's what you may mention. Now it can be done either ascending or descending, all right? Or don't short it. Another
Got
option is don't short it. So don't short it means don't put it. So if you put true, then it means ascending. If you put false, then descending. If you don't want to do it, then remove it. So three possibilities are there.
So true is for
okay, sir.
manufacturer and false for year of purchase.
Yes. So however way you write here, that way you have to give here. Okay. We can move to next.
Here the
Uh,
first option is true according to this.
yes. First choice true. Short values is the thing we have to use, right? Okay. Now, which for option will give the count of flights that have a delay greater than the average? So first we have to find the average in delay. So this can do delay and then mean of that, right? So this three are mean of them. Now we need count of that, right? So count of flights. Okay. Mean, then TF delay minutes greater than mean, greater than that. Then we can do how many are there, and then find shape of it. Okay. So rows. This looks okay. Now if I do count of that, it will give me the whole the whole thing, right? whatever data frame comes out of it. So the whole DF shorted using this, and less than will not work. So I think the first is the right answer, not this count. Count will give you all of the things uh, like let's say if I do DF year of purchase greater than 208, and that if I use for the sorting, it will give me the whole thing. Okay.
Sir,
The
we
whole
need
thing.
how many minutes it is delayed, not how many times it is delayed. So that is why some.
If I do count of that, then you can see it's give me something
Yes,
different.
how many
But
times it is the flight is delayed?
yeah, so this kind of thing we don't want. What we want is shape of it. That's all. Shape and how many rows are there. That's all, right? So that will work using first one. Like second one will not work because it will give me counts of so it is giving count of each column. How many values are there in that? So this is not useful to us. The third one. Okay, now consider the following data set and transform pipeline. So we have column transformer, then mean max scalar one hot encoder, KNN imputer, pipeline we are using. Okay. So this kind of data set is there. Some null values are there. We are using KNN imputer with n neighbor equal to 2 and mean max scalar. Now, okay. So when we use column transformer, we give a name something. We use a pipe in that, like, and anything you can use as a transformer. So here they've used this with the whole pipe, right? So this whole pipe will pass through that. Then they are saying that 0 and 2 column should go, right? So this is 0, where 2.5, 2.85 is written. 1 nan is there, which is 2. And 1 should go through 1 hot encode, right? Now they are doing the transform on that. Okay, so that's what we are doing it. Now, what will be the shape of transformed array after fitting the pipeline? So, uh, so you can see 1 and 3, or 0 and 3, 0 and 2 are not going to change in shape, right? Shape will not change. How many values goes in, that many will come out. Okay, because we are doing imputation and scaling. That's all. But one hot encoder is different. It will produce more column of it, right? So here it's a tricky. How many uh, unique values are there that we have to see? So red, blue, green, 3 unique values are there. So we will get 3 out, right? So 1 goes in, but 3 comes out. So we'll have 3 columns and 2 of this 0, 2, and 1 will produce 3 of it. So total 5, right? Yes, 5 should be there. So and rows will not change. So 4 rows, but 5 columns should be there. Okay. You got it? So this is the data. This was the question. Now, something we can do it. We can see this. Okay, so this is how the column transformer is forming. And in pipelines, this 0 and 2 columns will go, and first will go here. Now, if I do this, then if I do transform x dot shape, so that is 4 plus 5. And if you wanted to see how it is coming out, so something like this is coming out. Like, it doesn't look good. Maybe wait. Okay, so you can see this is 0, but this these are coming from or this C, right? Blue, green, and red are coming from the pipe. Like, naming is little bit off, but you get like that. This two are coming from the first one. This whatever this pipe is there, this pipeline, and second is coming from this one hot and cold. This all three. Now, what is next question? What is the value of transformed x 1 to b? So they're asking at so indexing always start from 0, right? So remember that. Now we wanted to find what is going to be at 1, and in the 0, 1, 2 second column, right? So basically count by third. So what will happen is this pipe will go first, right? So that will produce 0 and 1. So 2 will come out of one hot encoder, and in one hot encoder, which has the like alphanumeric way, which has the lower value, will come first column. So out of red, blue, green, blue is the one which is going to be the first column. Okay, formation wise. So blue, then green, then red. Right. So that's how the columns will form. And in that, I wanted for I think 1, right? 1 is the row. Yeah, 1 row. This is 0, 1. So here for blue, it's asking, so it should be 1,
0.
right? No, it is 1, right? Because first column will be 1, or we can see here, see, this is blue. For 1 they are asking, and this is what exactly the value they are asking it, right?
Yes.
To talk and visualizer, right? And so basically 1 is the right answer. Just think you have to visualize and maybe think about it. But here I have written that, so I'm showing it to you. Now, which of the following process preprocessing technique helps in handling categorical features in data set? So if I have categorical, then I'll do maybe one hot encoding if it is nominal data set. Maybe ordinal encoding I can do, right? That I can do. Label encoding, handling categorical features, right? So label encoding is also kind of true, but generally we do it for if it's label, right? It's not feature, but target. So I'm not sure if label encoding is right or not. It's a dicey thing, but otherwise one hot encoding is true. So label encoding is something we use when we are handling targets, right? So that time we use label encoding. Otherwise, ordinal encoding is the same replacement for the features. Which of the following imputation strategies can be used for handling missing values? Okay, filling with mean or median. Yes, we can do that. Deleting rows with missing values. Yes, we can do that also. Deleting or actually removing it, but I will consider that as deleting. Using a predictive model to estimate missing values. That is also we can do. We can use some model. So some model can be used, like decision tree. Decision tree, a model we can do. We can use it, and that will actually estimate what value should go there. I'm not sure it's covered in the course or not, but I don't think it's been covered. So we never asked. I haven't seen this kind of questions, or it's not there in this term. Okay, but for now the question is here. So yes, we can use model to predict or to impute missing values. Okay. This strategy is there. Decision tree is one of the example which is being used for doing this. Using random generator to fill missing values. I don't think so. This we do it or anybody does it. Uh, that's not possible. Or that's not valuable to do it. Which of the following is correct about cross validation? So cross validation helps prevent overfitting. So cross validation is something we do when we have multiple folds of data, or we make multiple folds of data and then use one fold for testing and rest of the folds for training purpose, right? So um, yes, it kind of prevents overfitting, because otherwise what we would have done is we have used training and test set, right? One set of training and another for testing, and then run the whole data set on the run whole model on the one data set and then predicted other. So it would have lead to overfitting. But now we are kind of dividing data in several ways, then again rerunning the model and all. So it will kind of prevent the overfitting. It is technique to improve the model's accuracy. No, we are not looking for accuracy of model. We are not preventing any of that, right? So this is not true.
Sir, but if it is preventing to overfitting, then it is in directly to the model's accuracy, increasing the improving the model.
No, that is not the idea behind it. Model's accuracy could go down as well, right? Let's say if you just without doing cross validation, there is possibility that gradient descent could go in way, and you might have higher accuracy values. But but then some data set will come up and then it's not there, right? So it's not
So
true. Like
cross validation we do for this tuning the this hyperparameterization.
Hyperparameter, no, that's why we don't do it. We do cross validation because if we do just train and test, then model will overfit. To prevent it, we divide data set in several batches and then train it again and again. So we use one batch for test purpose and rest we use for training purpose. So it's not necessary that you do it for hyperparameter tuning. So hyperparameter tuning is, I know it has like inherently sklearn does it, and that's why we think like that. But hyperparameter tuning is something we have several like grid like thing you can think. All the parameter values are there, and we choose one and run it. Choose another and run it. So that is something different. Like let's say without cross validation also you can do it. That hyperparameter tuning. That won't be much efficient, but you can do it.
Sir, accuracy is a metric for logistic regression, but cross validation can be used for linear regression as well, right? That could be another.
Yeah, you can
justification
say that.
per second.
Yeah, correct. That is also a valid point. Yeah, so generally cross validation is not something we think about accuracy in that point, but we think about overfitting. That is the idea behind cross validation, to prevent it. is one of the okay, maybe we can put it. So popularity is a subjective thing, but okay. Cross validation is not suitable for small data sets. Okay, this is kind of true. Because what happens is, if you have a very small data set, then like training a model will require little, like some sufficient amount of data should be there to train one model, right? That is the idea. But if you use batches in that and then trying to do cross validation, it will not train any models, right? So all the models will be half trained or not efficient, not appropriately trained, right? So you need some amount of data to actually use cross validation. So this is true in a way.
Sir,
Which of the following are yes?
sir, in cross validation, sir, different fold have different type of training set.
Different type of
Training data.
uh, in each fold.
Yeah, for in each fold,
Hmm.
suppose we have a data set, and each fold we have to put different type of data.
No, we don't have to put anything. See, this is our data set, let's say. So you can create fold of, let's say, 2. So let's say this 2 is a fold. Now it's a batch. So one fold you can consider as batch or something. You can think like that. And let's say this is another fold. Now 1 and 3 is also another fold, right? So this 3 folds are there. That means 3-fold cross validation. Okay. Now what you can do is, let's say you can use this first fold for testing purpose and rest 2 for training. So this much data set will be used for training and first will be used for testing. Now in next run, what you'll do is you will use this 5 and 0. Okay, so 5 and 0 you will use as a testing, but rest all you will use as a training. So that's how you do fold, a fold cross validation. We don't have to use any different data set. Just training data set we have, we'll use that only. But we'll divide in batches and then do
Batches.
yeah. So batch is called fold now. Okay? Think like a paper. So paper kind of thing. That's why the fold is coming up. Like you use one fold and rest of the paper for the training part. Okay. Which of the following are valid loss function? Okay, so SGT, this is a classifier. Okay. Now, okay, mean absolute error could be not be there. Log loss could be there. Or so this is something you have to remember. And so what are the losses there? So there are like this is a classifier. So there is hinge, log loss is there. Modified Cooper is there, squared hinge, perceptron, squared error, Cooper epsilon. So now it has increased a little bit. Earlier, few were there. So okay, so this all are there. So one of that, yeah. So I think hinge loss is there, squared loss is there, but not mean absolute error. This is understandable. This comes under like regression kind of thing. Now, okay, this is something related stratified k-fold. And we have x and y stratified k-fold split in 2 k. So we are asking what is strain and test indexes. Okay. Stratify.
First and fourth.
First and fourth. Okay, so the idea is we wanted stratified means we wanted y, right? So here we have used y as a stratified column or something. So it should have equal amount of equal proportion of y or different categories in all the splits. So equal to the original split, right? So here you can see y has 0 and all, so both are 50-50%. Now if I do a split, that should also have 50-50. So it shouldn't be like equal to 50. Here it is going to be, but it can be like 48, 52 is also valid. Okay. Sometimes it happens, like if you have huge data set, then you might see this kind of little bit change in the little bit change, not much. Okay. So here we'll see 50-50% we want. So which of this has 50-50 y, that you have to see, and that is going to be answered. The logic is you have to see the y which has 50-50, right? So here if I see 2, 5, 6, so 0, 1, 2, 5, 6, 7. Okay. So this doesn't look to me stratified, right? 0, 1, 2. Okay, sorry, my mistake. 0, 1, 2, 3. So 2, 3, 4, 5, 6, 7, right? So okay, so this is yeah, this is stratified, divide in equal. 0, 1, 2, 3, and this. This is not correct because we wanted two splits. So it will do equal splits, right? If it was three splits, then it will do three equal splits. Like here we don't have 9, but 8, like it will do, I think, 3, 3, 2, something. But as of now, we don't have to think about it. Like it has equal, like 8, which can be divided into 2. So this can't be right answer. Now third is 0, 2, 4, 7. So 0, 2, now 4, 7.
So it has to be equally distributed, right, sir?
Yes. Yes. 0, 1, 2, and 7. This doesn't look like a right answer to me. So third, but it can't be a right answer. Now fourth is 0, 1. Now this is 3, 4. Yeah, so this is 0, 1, and 3, 4. Now rest of them are here. So this is also right answer. Okay. So the logic is I'm seeing where y is equally distributed and both of them. Okay. Stratified k-fold. Okay. Now this data set is given to which of the following pairs of data points have the second largest Manhattan distance. After imputing the missing values with the column mean. Okay, this is a little bit tricky, a little bit time taking. So first you have to do is you have to impute with the mean, right? That is the idea. Like let's say the first here is a mean, is a null value. So if you impute, you might get some values, but let's see how we can do. Like, can I do it faster? Is it possible? So I want pairs data have second largest. Is it necessary, this question? 2, 3, 0, 1, 2. Sure. let's see. So as of now, I'm not using pen and paper, but what we can do is, so this is there. Now they are saying me that impute with the mean. So if I do like 1 plus 3 plus 2 and divide by 3. So that is 4 point. That should be 2. So first is 2, and I can do that. I can put 2 here because that is going to be the value of it. Now in third column, I have 3 and 5, right? So if I take mean of that, now here's something like maybe you can consider divide by 2 here. That's not mentioned in the question, right? I haven't seen like ignore the missing values or something. Yeah, or they haven't mentioned like SQL and impute also. But still, I'm considering that we are ignoring the missing values. Otherwise, I should divide by 4, okay? And that is 4. Like so here it should be 4, and here it should be 4. And now last one is remaining. So 4 plus 1 plus so we have 4 plus 1 plus 10. That is 15 divided by 3, which is 5. Okay. Which is 5. Okay, so this is what I did using imputing mean. Okay. Now they are asking which has the highest imputing second largest. Okay, not even the largest, second largest. Let's see. So this is tricky. How should I go with it? Can maybe figure it out
2 and
largest.
3.
Huh? Sorry?
So 2 and 3. It is second high.
But so how did you find it?
So first we find the mean of the where nb.nan, and then we find the difference between two rows.
So you did for all of them?
Find 0, 1, yes, 0, 1, 0, 2, 0, 3, where 1, 2, 1, 3, and 2, 3.
So how much time did you?
So I did previously. That's why.
Yeah, no issues. But how much time it took you? Like,
I think not too much time because it is find the Manhattan distance. That's why it is
only difference will tell, sir. Some of the difference will tell.
Okay, yeah, correct. So
what is the difference? Some of the difference will tell.
Some, yeah. So difference you do and
absolute some of the difference.
Yeah. So but still it will take some time, right? I think.
Not
yes,
so
sir.
much
It will
time.
take.
Okay, so let's say if I do first 0 and first row, I'll show you that. So let's say 1 minus 2 is 1, and I'll take absolute value, so 1. Then I'll do 2 minus 5, which is 3. Then I'll do 3 minus 4, which is 1, and 4 minus 1, which is 3. So I'm doing 0th row and first row. So this total is the distance between them, 8. Okay. Now same thing I have to do with 0. Maybe I'll do whatever given to me. So this 5 thing I have to do. 2 and 3 I can do. Like what is 2 and 3?
Second row and third row.
Right. So 3 minus 2 is 1. 4 minus 2 is 2. And 5 minus 4 is 1. And 5 minus 5 is 5. And that is something 9. 0 and 3. So 0 and 3 is 2 plus 2 plus 2 plus 1. Okay, something like this. So this is 7. Now if I go 1 and 2 and 1.
0 and 3.
Yes. Yeah.
So how you're actually adding, sir? How you're actually adding? Yes.
How or why?
Yeah, from where we are. I did not get this.
You did not get
0
this.
and 3.
Okay. So
yeah,
this
for 0 and 3.
Okay. So this is 0th row.
Okay.
And this is 1, 2, 3 row. This is third row.
Okay.
Okay. Now what I'm doing is, so you can see 1 minus. Oh, I think I mistake this. This should be 1. This should be 0. Okay, what maybe I took 0, 1, 2. Second row I took. Sorry, that is my mistake. This should be 6. If this is correct answer. My bad. So this is 0 and 2. 0 and 3, not 2. 0.
Okay, we are taking the row 0 and third and we are subtracting. Okay, got it.
Yeah, we are subtracting it. That is 1 and 2. So if I do 1 and 2, which is this 2. So if I do for both of them, that is like 1 plus 1 plus 1 plus 4 plus 1 plus 1 plus 4. So absolute you have to write. Then 1 and 3. So 1 and 3 is going to be 2 minus 2, 0. 5 minus 2, 3. 4 minus 4, 0. 1 minus 10 is 9. I think this is already out of picture. So we take second largest, which is 9. So we figured out that this should be the answer. 2 and 3. This was not. So yeah, it is little bit large. Like I used calculation power and all, but you have to do it manually. So there is a high chance of mistakes. Now what is this? Function transformer. So in function transformer, what you have to do is you have to give a function. That this function uses and transform my data using that. So we are using np.nan to num x nan equal to 0. I have, so I get the idea what is function, but I have dot nan to num missing one position argument. So I think I should give something here. Yeah.
Sir, it replaced the none.
Yeah, that I get it. So
Sir,
I
X
get
value,
it. That it has to
take
be,
X value np.nan to replace.
yeah, then replace it with 0, right? That's
Yes,
the
sir.
idea. So I get that. So yeah, so this is the program of it. So this kind of thing is given. Now it's saying that replace x. So x is something we'll give, and it will replace it with 0. Okay. So if I do it, and if I show you the transform data as well, that will all zeros. It's like kind of understandable from this.
It is all none np.nan to 0. It's
yeah, nan to num. Then it's like nan
kind
is
of imputing with 0.
Yeah, imputing with 0. You can use anything. Yeah. Okay. So it's quite understandable. So that is okay. Now it's asking which of the following correctly represent the value transform data to 0. So second row and 0. So 0, 1, 2 here. So this value we are asking, it is 0. Okay. This is the value we are asking, which is nan now, but after replacing it will be 0. Okay, something is there. Pipeline considered now. So what is the question? How many different models? Okay, different models will be trained using this grid. Pipeline is used for feature scaling and apply SGD request for hyperparametric tuning. Is 100 and features fine feature pipeline.
Sir.
Now this is the grid where everything is working. So we have polynomial degree, regression. So for regression we have different, and then
36.
polynomial we are different. So okay. So what it will do is, let's say it will choose one, and then it will choose one variation of all of this, right? Alpha, penalty, and learning rate. One variation of it. So here it will produce 3 cross. So it doesn't affect actually. Like we can just directly multiply and
yes, sir. 3 into 3 into 2 into 2.
Right? 3 into 3 into 2 into 2. So there is no like so sometimes what happens is, let's say some values are there which are like which doesn't produce multiplication, but they are like addition kind of thing. Like that variation is also exists, like but here it is a multiplication kind of thing, because at a time if I choose 1, then rest of the variants will not affect. Like, it will not be addition. Okay, it will be multiplication only. So 3
Sir,
into 3.
what kind of things will make addition?
So where you can use, so here we have used one dictionary. So sometimes you can use maybe 2 dictionaries. So that kind of thing will produce addition. I don't like recall exactly the code or something, but that is also a possibility. That addition could be there. Like here, why we are doing multiplication is because they are
okay. Such
at a
two
time, like,
dictionaries
it is
are
an
there,
agreed,
then
right?
plus 2 times, right?
Yes. So here, let's say if I do 3 plus 3, which is 9, into 2, 18, 236. Polynomial degree. Yes, so it should be 36. Now the question is, how many different models will be trained? Different model. Okay, that is you have to take, because cross validation is 3. So one kind of model is being trained 3 times, right? So out of that 36, right? 36 models are there, will get trained. Then you'll get 108 models. But that is not the thing. The question is how many different models. So cross validation type models are all same. They have same parameters and all. Just data is different. But they are same. So 36 is the right answer. Okay. I don't know if you can.
Sir, how you calculated this? Like a 36 different model?
Multiplication of. So 36, right? So so here it's a grid, right? So grid. What you have to do is, in grid is, you have to just consider that at a time you can choose any one value of it. Okay, at a time. So all of them you'll choose one value. So 1, 0, L2 and constant. That thing you'll do. And next variation you can take one as a let's constant, and others you have to replace, right? So this is, in that way it will become permutation combination, but ultimately you will end up doing all these variations 1, 2, 3 of polynomial degree, all variation of alpha degree with the other one, and that's why it is a multiplication of all of them. So multiplication is like 3 into 3. So as many values given. So here 3 are given. So I'm multiplying 3 with 3. Then 2 values and then 2 values. So that many variants can happen. Okay. Now you are working on a machine learning project, numeric categorical, okay. Values given data following cleaning certificate. Use one hot encoder, impute. Third is remove duplicates, standardize, identify and handle outlier, most appropriate sequence. So if I do first, we'll use one hot encoder, or I use remove duplicates, or we use impute missing values. Or this is little bit questionable. But we can maybe go with all first step. So first, if I do, then I'm doing one hot encoding, which is okay. You can do that. So then I'm doing fourth one, which is standardizing numeric feature. So yeah, it doesn't affect the first step, right? So first and fourth step are kind of parallel. They are not affecting each other. But then if I do two, so then I do imputation. After standardizing, I can't do imputation, right? That doesn't make sense. So first I do imputation, then I do standardization. So two should always be before four. So first option can't be true. Now in third, I can remove duplicates. Then I impute missing values. Okay, that is okay. I can encode I can encode category data. That is also okay. I can standardize or normalize numerical feature. That is okay. As per your imputation, that is okay. Identify and handle outliers using IQR. That also I can do after it. So second seems correct. Second seems correct. But let's see, is there any better? Okay, in third option, what I'm doing is I'm first imputing it, then removing duplicates after imputing. Then I'm encoding it. Then I am finding the outlier, removing it. Then I'm scaling it. So kind of like second and third option, both are kind of correct. They both are correct, but still I would I'll choose C option. The reason is that identify and handle outlier using IQR method. Like it will not affect. So does Z score will affect? Yes, I think it will affect, right? So Z score will affect my how do I handle outlier and all. Using IQR. Wait. This is interquartile range and all, median and all. It will kind of affect it, right? So if I do it, then the range will reduce and it will kind of affect it. So I still want to do fifth step before fourth. So that's why I'll use third C option as it. Now what is the last is like remove duplicates. Then I remove outliers. Then I do imputation. Then I do one hot encoding. Then I do scaling. Okay, this also seems okay. Yeah, so I think this question is a little bit incorrect because third and fourth both are almost same. There's nothing different about it. Okay, so you can do third or fourth, anything. Removing, yeah. So maybe okay. So I think this I'll leave it as a doubt of this, but my answer would be 3 or 4. Both can be right answer. Okay, now import pipeline. PCA is applied. So how many components does PCA reduce the data to after transformation? Okay, so it will reduce to 2, right? That's what it says. Reduce to n components equal to 2. So it will do 2. I don't have to read the whole code. Now consider the below code. I wanted to standard scalar. Okay, I do that. What will be the output of this snippet? Okay. Now, if I do standard scalar, so in standard scalar, I first find the mean, subtract from that. So the mean of first value is 0. So, and standard deviation is, I have to find the standard deviation or something like that. Okay. Let's see the options. Mean is 0. Standard deviation of this should be like 3 plus 3 square, right? 3 minus 3 minus 0 or something like that, which will not affect anything. So 3 square 9 plus 9 plus 9 plus 9, and divide by 4. 18, and so what I'm doing is like let's do because that's what it is. Now I have to find standard deviation or variance. Actually, I have to find, because the formula of standard scalar is, what I'll do is I'll do x minus mean and divide by standard deviation, sigma, not variance but standard deviation, the square root of variance. So mean is that. Now let's find variance and then we can do square root of it. So if I do variance, then that is minus 3 square, right? So minus 3 minus 0 square. That's what I have to do. So that is going to be 9 plus 9 plus 9 plus 9. That is the summation of it. Now I have to divide it by 4. That's what the formula is for variance. Yes, that is going to be, if I do this, that's going to be 9 only, and then square root of that is 3. So my is equal to 3, right? So if I wanted to transform now, I can, what I would do is minus 3 x minus mean divided by standard deviation, which is 3.
Sir, mean is 0.
Oh yeah, sorry, mean is 0 here. Yeah, sorry. So this will lead to minus 1, right? And if it's going to be plus 3, then I'll have plus 1. Fine. So minus 1 plus 1 plus 1. Okay, let's see where is that. Minus 1 plus 1 plus. So I think from that only I can figure out this is the answer. And second one you can do it yourself. Okay. Now what is it? What is the purpose of total tolerance parameter in SGT regressor? So what does tolerance do is, in each iteration, some, like the loss will reduce by some amount, right? Some amount it will reduce. So it will, after some, if it's not reducing by some level, then it will keep like keep on running for so many iterations, right? Just 100 iterations are given. It will run for automatically, like by default it should have run for 100 iterations. But what we can set is, like, let's say if loss is not reducing by this level, then check for 2-3 iteration. If it is not above this range, then stop it. So that is the idea behind tolerance. So learning rate, no, it will not control learning. It determines maximum number of iteration. It will not determine that. It defines the fraction of the validation set used for early stopping. No, it specifies the tolerance level for early stopping based on the change in the validation error. Yeah, so that's what it is, right? So error, it will validation error should be greater than this to have another iteration. what will be the output of the following code? So I have 1, 2, 1, 2, 1, 3. Then dictionary, then I have this value. So I should have 3 features, right? At least 1, 2, and 3. So either C or D. Then feature 1 has value 3 and 2. And feature 2 has value 1, only 1. Feature 3. So I think it's like so it's like 2 rows. First has value in first and second. So like this, first and second has values. Another has values in second and third. Sorry, first and third. First and third, like here. Here it has first and third and first and second. So that's what it means. Dictionary factorizer. Okay. Now, what is the np dot array? Some function is being created of that 1 1 1 2 2 2. Then np dot x and y plus 3. So something here you have to solve it, right? So yes, you have to solve it. So let's see what is y first. That's so this thing you have to do. So like you have to write x, then matrix multiply. So dot is matrix multiplication. You can have x and then matrix multiply with y, and you'll get value for each of them. Right? So let's say for 1 1 you will get like 1 into 1 1 plus 1 into 2 2. That is 3, and the intercept or not intercept plus 3 is given. So that will, because of that, plus 3. So that's why you'll get 6. Okay, the second row you'll do 1 into 1 1 plus 2 into 2 4 and 3 more. So that is 8. And so 9 and 11 another thing you'll get. Now they are asking fitting. So okay, let's fit it. So x is this, y is this, 6 8 9 11. Maybe we can have it like say np dot array 6 8 9 11. Okay, so on this I have to fit. Now just look into this too. Now I have to fit a linear regression here. Okay, let's do that. 2 3. Intercept is this, and coefficients are this. Actually, what I'm doing is, if you actually see what we are doing, let's say W1 X1 plus W2 X2 plus W0 is the term, or I'll just write C for intercept, right? So C is something I'll write. So we can use W1 as 1 and then some value of X1, right? Plus 2, then some value of x2, whatever is coming from the data, and the c, which is 3. So this all is given here only, right? So this I can, 1 as I can take as a w1, 2 I can take as w2, and 3 I can take as c. So that's what it is, and that's what I'm going to get as a coefficient and intercept, right? So if I do this, and I run it. I get 3 as a, you can consider this as 3 only, and 1 and 2 as a coefficient of it. Correct? Like that's what the y is for, and same thing we are getting here. So intercept should be 3 and 1 and 2, which is 2. So I don't have to draw and anything. I can do that also, but not at all. Okay. Okay, so this is the last question. Which of the following best describes the purpose of an iter, no change? So this an iter, no change, what it does is that if for some iteration, so you can set, let's say 5, 6, any value. So any value is that if my validation error is not changing, okay, in this iterations, no change, then stop the iteration, right? So stop the loop. That's what it is. Control the total number? No. Specify tolerance levels for early stopping? No. Defines the number of iterations with no improvement to stop training. So if there is no improvement in validation error, validation score, then it will stop the training. And that is the concept. Okay? So that's what it is. Okay. 41, somewhere we made a mistake, but that's it. Okay. Where is it? Oh, here we didn't put anything. Okay. So squared loss is actually that. Or error. Okay, it's squared error, not loss. Small data set. This is true though. I'm not sure, but that's okay. Yeah, so that was it for revision session. If there's any doubt, I can take. Otherwise, we can close the session.
Sir, how you did the second last question, sir?
Second last question, how I did it. So this one. So as I said that this is the equation of linear regression, right? This is what we are going to make as a linear regression. Let me write WC. We are familiar with that. Is it okay? Hello.
Yes, sir.
So this is what equation is there. Now they've already given us what is W1. So if I do W1, if I use W1 as 1 and W2 as 2 and my intercept as 3, then I'll get my y, right? Y hat or something. Like this is true y, which we calculate using this. But if I wanted to again recreate it, how will I do it? So if I use same intercept value, same coefficient value, then only I can achieve it, right? That is one of the answer which I can use. So that's why I use 1, 2, and 3. It's given in y only. So this y was given to us. Right? This y was given to us. So, okay, right. So this np dot x and y. This np array. You can consider like 1, 2, 3 are given as coefficient and intercept, and solve it. Fine.
Actually, the formula is x6 inverse into xy. So if you do that from x and y, you
got
can
it, sir.
That also you can do x inverse and all
from
inverse
MLP
and but finding inverse is difficult.
Yeah, since they had given it, it's easier. True way.
Yeah, y is
yeah.
So
It's already given y, so that is why the intercept is there 3 and the coefficient is 1, 2, right?
Yes, yes.
Okay, sir.
Sir,
Yes.
sir, what is the difference between sir cross well score and cross validation, sir? When we will use
So
cross validation and
Crosswell's
cross.
okay. So Crosswell score will Crosswell score will give you score only. Okay. Cross validation will um, there's a minor difference in it, like not much. Both the same thing, but cross validation is something will give you a model of it. Crosswell score will give you score in it, like I got it, like
And so both are preventing overfitting.
yes, yes, both are same thing only. It's just something think like how I think like that. So cross validate inside it you use crosswell score. Okay, so let's say you want score of this cross validation, then how will you do it? So it's like, see how you write a Python functions. You if you have, maybe you haven't done maybe like this, but we create a file for it, for that function, then we import that file inside another file to use it. Okay, that's how we do generally, and that's what they are doing. So they created crosswell score, which is a function, then they are importing inside a cross validate. Okay, so if you want score, like here so you can see return score, by default it's false, but inside it it's used crosswell score. Okay, um, so the scoring part is something is handled by that function. So there is nothing difference between it. Both, like cross validate is the thing we want to do, and crosswell score is something we use it for it. Like so that's all. That is the only difference between them.
Okay, sir. And sir, how it prevent overfitting, sir?
Oh, okay.
Because
How it prevent overfitting? So okay. Okay. Let's say I have one data and I split into two, train and test, and I do the training on that train set, right? So train set is there. I do training of my model on that. Okay. Now, now what will happen is uh, let's say gradient descent kind of model is there. Okay, one of the easy to explain. So in gradient descent, it depends that what is the next next data comes into the model. Okay, because it will change the direction of my gradient and all. So it really affects the direction of gradient. Now it could be there that one kind of thing can lead to one certain direction, and it will go in that direction only. It will never change the direction. But if you do cross validation, then what you are doing is you are training multiple models with different data set. Now you are saying that this data set is there. Now it's coming in different order. Different order is coming. Then multiple models are forming. You are taking average of that. So now gradient descent can happen different ways also, right?
Yeah.
So that is a prime, like that you reason you can consider for like not overfitting it. Okay. And overfitting happens like what is the main reason that overfitting happens is that model learns from the data as it is, like it learns data too much learning from the data. But if you give data in different variations, different batches and something like that, so this all small things will help you reducing the overfitting.
Okay.
Okay. um, yeah, next question. The question is that okay, thank you everyone. Close the session. Best of luck for the exam. Just go through previous year question. I think you will be able to score well. Nothing much. So this link I shared now, the last link, this one, has all the papers. I think most
Is
of
there
the
any
papers.
other course like tomorrow? Do we have any class?
Tomorrow, do we have a class? I think not there. I think maybe TA session, if it's there, then. But yes, Friday TA session is there, right? So the TA session will be there. And
We can check any doubts there.
yeah, you can post on Discourse as well, or you can check in. Yes, TA session will be there. You can ask doubts. 8 o'clock.
Thank you.
Mhm. Okay, thank you. Bye then.